All right, today our focus is going to be on finding slope and y-intercept. Now, finding slope we focused on most predominantly yesterday, so that should be the really easy part of today's lesson. Finding y-intercept, I don't think you're going to find much more challenging. So let's look at some examples on a graph. Before we jump into the graph, remember that finding slope is rise over run. You can certainly use the slope formula. It's going to be a little bit longer. So I would recommend just getting used to rise over run. Finding the y-intercept. The y-intercept, and I would recommend writing this down, is your b value in your y equals mx plus b slope intercept form equation. So it's beneficial for you to recognize this equation as the equation of a line in slope-intercept form. So your y-intercept is the point at which the equation crosses the y-axis. Well, that should be a really easy place for us to find. Let's look at some examples. All right, start with the slope. Moving from left to right on this graph, we can see that the graph is declining, going down. It's got to have negative slope, so m is going to be a negative value. Find two places where it intersects perfectly, and rise over run. So in this case, I'm going down to, well, that's my negative, over 2. And we can simplify. Negative 2 divided by negative 2 is equal to negative 1. So we have an m value of negative 1. Now, I'll give you a big hint. Typically, when you see an m value of negative 1, your graph is connecting at every single one of these intersecting points through the squares. That's normal. Oh, sorry, I forgot one thing. Our y-intercept. We already said that our y-intercept is where the graph intersects the y-axis. The y-intercept, notice, I'm not moving left or right when I'm on the y-axis, so it has a x value of 0. We're going to go ahead and get used to writing our y-intercept with an x value of 0. So when x is 0, we come down 1, 2, 3 units. That gets us on our graph. Negative 3. So our y-intercept is equal to 0, negative 3. All right, let's try another one together. We want to find perfect intersecting points. So it looks like we have one there. Ooh, messy line. And one there. So we're going to start with rise over run. I have a line that is increasing from left to right. So as my x's get larger, my y's get larger, which tells me I'm dealing with a positive slope. And now I want to know my rise over my run. So let's see, we've gone up 1, 2, 3, 4, 5, 6, 7, 8. We have a rise of 8 over a run of 1, 2, 3. Our m value, or our slope, is 8/3. Now, don't try to change it to a mixed value. Don't try to messily change it to a decimal. Just leave it a simplified improper fraction and move on. So our y-intercept, again, where x is 0, we want to figure out where our graph intersects. So that's up 1, 2, 3, 4. So we will have the ordered pair 0, 4. All right, see if you can give this one a try, and then come back and check your answer. All right, looks like I have two intersecting points. So m is equal to negative, because my line is decreasing. We go down 1, 2, 3, 4, 5 units. We go over 1, 2, 3. So my m is negative 5/3. My y-intercept. That's the point where x is 0. Find the point where that intersects the line. That's going to be 0, 1. How'd you do? Hopefully you're doing all right. Let's try another. All right. Well, this one's interesting. I'm not rising at all, but I'm running. Okay, so I have a rise of nothing over a run of, 1 or 2 or 3 or really any number depending on how far I want to stretch. But what is 0 divided by 1? 0. What was 0 divided by 2? Still 0. 0 divided by 4? Still 0. The reason why it's 0 is because we have a constant line. There's no change in slope. So we can say that the slope is either 0 or we can say no slope. I'm fine with either of those two answers. Now the y-intercept. The y-intercept when x is 0 is going to be right there where the graph crosses the line. So 0, negative 1. All right, try this one. Tricky. Hopefully you remember that the slope from yesterday's conversation is undefined. You do not have a slope for a vertical line. There is still an equation for a vertical line, but we call the vertical line an x equals equation. And we identify its value by where it's at. Over 1, over 2, over 3. So x equals negative 3. Now, we'll talk about that more as we move through the year, but right now we want to recognize that m is undefined and identify the y-intercept. Now the y-intercept is the point at which this graph intersects the y-axis. Well, we can see that the two lines are running parallel to each other, and our understanding of parallel lines from way back in Unit 4 is that parallel lines will never intersect. So we just say not applicable or none. Please do not say 0 for the y-intercept. 0 is not the same thing as none. 0 is a location on the graph. It's an incomplete location because you're only giving me either an x or a y, but it's still a location. Not applicable or none is a more accurate or a proper answer. All right, extension, remember, y equals mx plus b is our slope intercept form for the equation of a line. So, what is the slope and y-intercept? Think on this for just a second. Okay, this one's really easier than you thought. The slope, the value in front of x, m is equal to 5/4. And the y-intercept, the value sitting in the b position. Oh, not, why did I write 4? 0, 10. All right. Now, there is a more mathematical process for determining that. And that comes from this value of 0 for x. So if I plug in a 0 for x, I get 5/4 times 0, which is 0. That eliminates this entire portion of the equation. And notice that what's left is y equals 10. That's why the b value is our y-intercept. See if you can figure this one out. All right. hopefully you realize that y is not in its correct position. We're not in slope-intercept form. For those of you that are listening and paying attention, this is actually standard form. We'll talk more about what that means as we work through the year. But before we do anything with this equation, we want to isolate the variable y and get it all by itself so that we have a y equals mx plus b formula. And I'm going to accomplish that by moving 2x to the opposite side of the equation. So we subtract 2x from both sides. 2x minus 2x is 0. And 0 plus y, well, that's simply y. So y equals negative 2x minus 7. Now I look like slope-intercept form. So my m value is the value in front of x when we are in slope-intercept form. My b value when we are in intercept form is the constant at the end. That is our y-intercept. And that's all we need to know for slope and y-intercepts for today. Have a wonderful day.